combinations 2 raised to the power k minus 1 and whole minus 1. Here in this case, three possibilities are there. So you can see 2 raised to the power 3 minus 1 minus 1. So here 2 raised to the power 3 minus 1, that is 2. 2 raised to the power 2, that is 4. 4 minus 1, that is 3. So in this way, you can calculate the combinations and you can apply this algorithm. So this is the working of ID3 and card algorithm. Now, splitting criteria, although if some of you have applied decision tree in any your work in your research work, so you can maybe you are aware, you will be aware that sklearn contains the in general these two criterias, Gini and entropy. sklearn library contains the two criteria, Gini and entropy, splitting criteria, of course, and you are not supposed to do anything, simply import the packages and apply the algorithm. But if you are going to apply some other criteria, so maybe you have to write the code from scratch because libraries are not available. Or maybe you have to import some other packages which is in which they have implemented. So you can see information gain we have applied in this ID3 algorithm. If you are looking forward to explore more about this ID3 algorithm, information gain, then you can explore this literature. And Gini index we have applied in the cart as I have just discussed. And this gain ratio, might be you are aware that C4.5, this is one of the variant of ID3 algorithm. In that this C4.5, we apply the gain ratio, which is normalized value, or maybe information gain with respect to per unit entropy. Gain ratio is defined as information gain with respect to per unit entropy, and you can explore this literature for knowing more about this gain ratio. And there are other splitting criterias like likelihood ratio, chi-squared statistics. It is useful to measure the statistical significance of the information gain criteria. You can explore this literature. Here, Towing criterion, orthogonal criterion, and AUC splitting criteria. So this is one of the recent one. You can explore this AUC splitting criteria. You might be you will be aware that ROC curve, receiver operating curve, and the feature which is going to cover the highest area, that is going to become the root of the tree. So this is one of the very important splitting criteria which can be applied to build the decision tree. And these are the univariate splitting criteria. Univariate splitting criteria, that means whenever we are going to select node, it will be based on a particular feature, or maybe it will be based on only one feature. But here in multivariate splitting criteria, we can see that several attributes may participate in single node splitting test. As we have discussed in the cart and ID3, only one feature is responsible for splitting, but in multivariate, many features can play their role for, in the splitting of the tree, maybe forming the decision tree. Now, finding the best multivariate criteria is more complicated than finding the best univariate split. And for doing this, we apply the linear combination of the input attributes, and be used to find out which combination is the better one. Like let's in this the previous data set which I have used, outlook, humidity, temperature, and wind. maybe we are going to combination, let's C1 and C1 outlook, C2 temperature, C3 humidity, kind of we can try different combinations, and in the greedy way we can find out the best combination, which is going to be the most suitable for using for doing the splitting or for building the decision tree. And linear programming, so of course whatever the expressions we are going to form, it will be in the linear manner, and linear discriminant analysis. So these are the approaches which can be used to let's build the decision tree using multivariate splitting criteria. Now, uh, when to stop splitting. So, as you have seen in the previous two algorithms, ID3 and card algorithm, we have seen that terminal nodes are going to have the information belong to a particular specific class, whether it is yes or whether it is no. But many times, in real world data set, we have very large number of attributes. In the previous data set, we have seen that there were four attributes only. But when we have very large number of attributes, then definitely it stopping criteria is going to be a key concern. How? Because when we have a large number of attributes, then it will require a very large number of splits, very large number of splits, and such tree take time to build and can lead to overload, overfitting, lead to overfitting. So here, the point is when we are going to let's build the tree and it is going let's having very long depth and covering each and every point, so maybe it will suffer from the overfitting. And when some algorithm suffers from overfitting, then what it does, it performs well on the training data, but it lacks in performance in the test data. So definitely we have to look for the let's stopping criteria, stop splitting criteria, where we have to think wisely, where we have to stop the let's this algorithm, this building the decision tree. So there are many ways to tackle this problem, and we can do it with the help of hyperparameter tuning. So you can see there are two types of parameters in the machine learning algorithms: model parameters and hyperparameters. So model parameters are in general fetched by the algorithms itself, and hyperparameters are tuned by the users. So here you can see when while applying the algorithm, you can set the max depth or maybe min sample split or min sample sleep. So when you are going to split a particular sample, I mean sample in the sense the number of instances, and with along with the target variable, so how many minimum number of samples will be must be there so that we can split. So these are the few constraints, and we have to tune for let's finding the better performance of the decision tree algorithm. Now, pruning is also, help us to avoid overfitting, because if we find that there are a few features which are not relevant for the data set. I mean, we cannot let's fetch the let's meaningful information from that particular features. Then what we can do, we can prune the let's those features. And of course, when we are building the decision tree, so it will be in the form of node. So we have to cut the nodes, which are less important for the decision tree. So in this we can see it helps in improving the performance of the tree by cutting. the performance of the tree by cutting as one of the best performing algorithm, because as per the accuracy wise there were some other algorithms also which were performing better or even equally performing, but when we look at the the processing time or maybe time complexity of the algorithm, so that they have find that decision tree one is one of the better algorithm, or in fact whatever the algorithm he has applied, decision tree one of the best algorithm. That's the